I'm Anil Kumar sharing with you some very interesting problems on pattern rules with blocks. The question here is draw two sets of diagrams for each algebraic expression 2n plus 1. Describe both the patterns, right? So we have a number of equations given, and in each I have just taken one. So this one is for 2n plus 1. So with 2n plus 1, we need to make this is our pattern rule. Okay, this is our pattern rule, which gives us total number of blocks. So 2n plus 1 is total number of blocks, correct? So that is what it is. So n could be equal to 1, 2, 3, and so on. So that is what this equation is all about. So what we need to do here is to make sequence of figures. Figure number 1 will be when n is 1, figure number 2 will be when n is 2, figure number 3 will be when n is 3, right? And so that this rule tells you the total number of blocks which can be used, right? So that is the exercise. Now how can we do it? When I say 2n plus 1, it means that if I have, let me write down figure numbers first. Let's say we have the first figure here. So let's say figure number 1, and then we have figure number 2, and then we'll have figure number 3, and so on. We could have figure number n. So n is the number of figures, right? Now we are saying that if the figure number is n, then the total number of blocks are 2n plus 1. However, if n is 1, if n equals to 1, then I can write 1 here. So I get 2 times 1 plus 1, and that is 2 plus 1 as 3. So I need 3 blocks to make figure number 1. If n equals to 2, then I have 2 times 2 plus 1. 4 plus 1 is 5. I need 5 blocks to make figure number 2. If n is 3, then it is 2 times 3 plus 1, which is 6 plus 1, 7. See, when you notice that I'm not putting times symbol here, I'm just making 2 brackets 3. It means multiplication, okay? So we have 7 blocks in figure number 3. So one thing we know is total number of blocks from the given rule. Now the second step is to make some patterns fit with this rule, right? So that is what it is. So when I say 1 to n plus 1, I'm saying 1 is fixed, right? So what I can do is 2 plus 1. So what this one is fixed for us. This one is fixed for us. Think like this. Think like this. It will help you, right? So I'm making one, let me say one triangle fixed. Okay. So in my each figure, I'll make that triangle, right? So this is how it could continue. Now the other figure I can choose something else, and let me use a different thing. Can we say, well, for the next one, 2 times 1, I need 2 things, right? So let me use 2 squares. Okay, so that means this is a good figure to make, right? So I have 2 squares, and in this case I need 4 squares, so I'll put 4 squares. Does it make sense to you? So this is a pattern, correct? And I can develop on this, and this time I can have 6, correct? So 2 more, that is it. So as you can see, the number of blocks here are 3, where the squares are increasing by 2 each time, whereas the triangle remains fixed. Do you see that? So that's the whole idea of the rule and the figure connection, right? So likewise, you can make different kinds of patterns to match the criteria. So what you can do is you can select some of the figures, play with your blocks, and make some patterns, right? So that gives you one solution for the expression 2n plus 1. And now I will show you another interesting way of doing the same thing, and that is what I will do this time is I will rewrite 2n plus 1 in a different way. So 2n plus 1 means there are n plus 1. Do you see that? So what I could do here is that I could combine these two, correct, and leave n aside. So I can make a different combination. Do you get the idea? So if I do that, then in that case, I'm making one block which is of a n and the other n plus 1. Do you get the idea? So I'll change the other one a bit. So what I will do here is, in this case, I will begin with n equals to 1. I have total 3 blocks, but since n is 1 in this case, so I have 1 plus, let me write within brackets, the other number, which is 1 plus 1. Do you get the idea, right? So this is here. So for the second case, when n is 2, so this will be 2 plus, and then we'll use the green ones as 2 plus 1, right? And then in the next one, what we could do is n will be 3 for the third figure, so I'll write 3 plus, and the green ones I will use 3 plus 1, right? So that will give me a new figure altogether. So instead of having one triangle, I can make a 1 plus 1 triangle, and I will have one square. So that also is a pattern, right? In this case, I can make two squares, correct? But I will have 2 plus 1 triangle. Do you see the pattern going on now? Now in this case, what I can do is I can make 3 squares, and as far as these blocks are concerned, I could write 3 here and add 1, right? So does that make sense? I should have preferred to put this one in this direction. Now I think it makes more sense. Do you get the idea? So I have n plus n plus 1, right? It looks like a growing pattern for the square blocks. They are increasing by 1, and the second layer of green triangles also increase by 1, and the third layer remains constant. Do you get the idea? So likewise, you can continue this pattern. So the fourth one will be, we'll have 4 squares here, right? Followed by 4 triangles and 1 fixed, correct? So what do I get? I get 4 plus 1, and that is my figure number 4, right? So that is, I will say, figure number 4. Do you get the idea? So likewise, what you can do is you can rearrange your blocks and make different patterns. Remember, the number of blocks remains same in the sequence of your pattern, right? So that is the whole exercise about. I hope with this you have learned how to use an algebraic expression to represent your patterns, and I hope that you are enjoying this journey with me. Thank you and all the best.